আমাদের লাস্ট প্রেজেন্টার হচ্ছেন I would like to call Dr. Mohammad Raju Ahmed, and his presentation title is Effective Design of Wind Turbine Grounding at Low Resistivity Soil to Minimize Grounding Potential Rise Due to Lightning. Dr. Ahmed.
Okay, thank you very much. At first, I'd like to introduce myself. I am Dr. M.D. Raju Ahmed, working as a professor, Department of Electrical and Electronic Engineering, Dhaka University of Engineering and Technology, Duet, Gazipur. And my co-author is Dr. Utpal Kumar Das. He is also a professor of the same department of same institute. I'd like to thank organizer for organizing this very nice conference, especially focusing on the technology related to 4IR. And I'd like to thank session chair and co-chair for their nice governing the session. So my topic is effective design of wind turbine grounding at low resistivity soil to minimize ground potential rise due to lightning. So this is some first, second, third, and fourth industrial revolution. And the fourth industrial revolution is basically concerned Internet of Things, cyber security, big data handling, etc., etc. And all of these things is related to the electricity. In order to achieve the advantages or challenges of fourth industrial revolution, we must have to ensure the continuity of electricity with good quality. So sustainable development of electrical power generation, transmission, and distribution is essential for taking the challenges of fourth industrial revolution. And all of we are aware that due to lack of reserve of fossil fuel, rising price, and global warming issue, we must have to move towards the renewable energy generation system. And on this issue, Bangladesh government also have set target to incorporate renewable energy generation system by 2030 and 2050. Potential renewable energy sources are solar and wind turbines. Wind turbines on average harness 60% of the energy that passes through them, compared with only 18 to 22% efficiency of the solar panels. So wind power generation is the leading renewable energy technology, generated 1870 terawatt hour electricity in 2021, as much as all the other renewable energy sources generated combinedly. In 2021, total 830 gigawatt of wind capacity installed, and 93% are onshore systems, while the remaining 7% is offshore wind farms. Lightning causes extensive damage to wind power generation system. Annually, 6 to 8% of wind turbines in Northern Europe get damaged by lightning. And this percentage is 14% in Southern Germany. And IEC technical report 61400, this is especially technical report for the wind turbine generation system. The most frequent lightning failures, more than 50% in wind turbine generation, are those occurring in the low voltage control and communication circuit caused by the rise in ground potential due to lightning. So this is some picture, lightning strike blades of wind turbine damaged at a wind farm, and there is also some picture of lightning damage. So existing work, many researchers worked on the lightning protection of wind turbine. They mainly focused on the protection of wind turbine blades. To design the wind turbine groundings properly, many researchers have been studied the tangent and steady-state behavior of wind turbine grounding at comparatively high resistivity soil. However, studies on the tangent behavior of grounding at low resistivity soil is very rare. So what we have done in this project, actually, to harness high wind speed wind turbine, you have to place the wind turbine in open air, and it's a very tall structure. So this wind turbine are frequently struck by lightning. And lightning damage in wind turbine blade and low voltage circuit, especially electronics and communication circuit, are very challenging for the expansion of a wind turbine. And in Bangladesh, due to lack of transport facility and wind speed, or big wind turbine installation of big wind turbine is not possible quickly. So government is planning to install a small wind turbine. So this is the picture of Kutubdia wind farm, the first 1000 megawatt 1 kilowatt wind farm in Bangladesh. So for this type of wind turbine, I have found when I have visited this wind farm, many wind turbines are damaged. But and many wind turbine blades are also damaged. But there was no recording system whether this damage is caused by lightning or some natural disaster. And another case is when the wind turbine is struck by lightning, the current is injected ultimately to the ground, and this causes the ground potential rise, and that's act as a high voltage on the transmission on the cables. So that causes the damage of the low voltage electronic circuit inside the wind turbine, which is very essential to operate the wind farm properly. So we have visited this Kutubdia wind farm with my students, and we have measured the ground potential, ground resistivity of this wind turbine, and then we modeled the wind turbine grounding using simulation software that is known as a virtual search test lab. That software is based on the FDTD method, which solved the Maxwell's electromagnetic equations. And we found that the resistivity of soil is very low as 50 to 100 ohm meter. And this is a very, very low resistive soil as compared to the other places. And this because of a very large amount of salted water exists in this grounding, so the resistivity is very low. So now actually what is the problem of low resistivity? I will discuss about that issue. So I model the wind turbine grounding using simulation softwares and inject the lightning current in the grounding system as shown in the right figure. Then we have analyzed the ground potential rise of the wind turbine grounding that will act as a over voltage of the communication or electronic system. So we found that for high resistive soil like 50 ohm meter and higher value, the steady state value and peak of voltage rise is almost same. But for low resistivity soil, the steady state voltage rise is very low, but initially at the front time, the over voltage is very, very high as at low resistivity soil. So you can see from here, the steady state voltage rise is around for 50 ohm meter soil, around 3 volt per ampere. So if we consider 50 kiloampere lightning current, it will be 150 kilovolt induced in this grounding system. Whereas the tangent voltage, that's at the front time, the voltage rise is 15 times, that is 5 times 15 volt per ampere, that is 5 times higher than the steady state level. So what we are doing now, we just install the grounding system and then measure the grounding resistance. That may be okay for the low frequency power signal, but for the lightning, this will not give us the correct result. We must have to consider the tangent behavior of the grounding system, which is very prominent and very significant in the low resistivity soil. And then we examine the effect of grounding rod. How can we reduce this tangent over voltage? We have examined a different location of the grounding rod, like at the bottom of the foundation and at the side of the foundation, using long rod or using short rod. And we have done the simulation, and the result is shown here. In this case, at the first figure number 6, you can see that using the grounding rod at the bottom, which is the Bangladesh, we are mostly practiced using vertically grounding rod for the grounding, is not effective for low resistivity soil. And for the figure number 8, second figure 7, it's a use long grounding conductor. It's effective but not so effective as compared to the short grounding conductor. So what we found here, for low resistivity soil, it's better to use several number of short grounding rod instead of using one long grounding conductor in order to reduce the transient over voltage rise in the wind turbine grounding system due to lightning. So we are now at the nearly at the end of my presentation. So IEC technical committee, they suggest interconnection of wind turbine grounding at a wind farm. So if there is a wind farm, several wind turbine grounding are generally interconnected in order to reduce the transient over voltage rise. But this condition is beneficial if the resistivity of the soil is very, very high. That is, if the wind turbine is located at the rocky place where the resistivity is high and water content in the soil is very, very low. But if it is located near the seashore, so where the soil resistivity is very, very low and soil contain a huge amount of water, in that case interconnection is not effective at all. So this is the one of the major finding of our research. And another one is, instead of using few long grounding conductors, use of several short grounding conductor is more effective to reduce the ground potential rise, hence the damage at the electrical and electronic system of wind turbine grounding. Placing of grounding conductors as close as the current injection point, that's mean the near the foundation, is more effective. Measurement of grounding resistance, it is not sufficient to predict the lightning over voltage. We have to analyze the system either by injecting the lightning current or by some simulation software that is handling the Maxwell's equation, electromagnetic equation. We have to do this before installation or during installation in order to estimate the over voltage. From the measurement of grounding resistance is not sufficient for the lightning protection of wind turbine grounding system. So this is the references I have used in these papers. So it's all about my presentation. Thank you very much for your kind attention. If you have any question or any suggestion, please you can make. Thank you very much.
Thank you, MD Raju Ahmed. I think nice presentation. We should at least clap for his presentation.
Thank you.
And now question answer session. Would you like to express any question, please?
Question regarding say due to lightning, if this accident happens, then what is the disposal? Because these are located in the remote places. Is one question. And in Bangladesh, it is sorry to say that we don't have correct wind mapping and solar mapping also. And the thing we were discussing in the previous session also, that we give the work to different companies, but they don't prepare the proper one. But based on those wrong informations, say like wind mapping, solar mapping, we are investing millions and millions of taka on it. So how we can overcome it?
Okay, thank you very much for nice question. Actually, Bangladesh is Bangladesh is not suitable for big, large scale solar power plant because it's required huge infrastructure change. Because you know the length of a blade now around 80 meter to 120 meters. So to move this kind of blade, you need special infrastructure that is not available in Bangladesh. So Bangladesh and that type of blade, especially when lightning strikes, it strike the blade because it is the top position. So now the latest technology, they use composite material, and inside this blade they use copper conductors. So and there is receptor and down conductor. So blade is very rarely damaged because the very latest technology, I can say you the technology used in Boeing 707 and the technology used in wind turbine blade almost similar technology. So this is very precision technology we are employing. But the problem is when any damage occur, it's very difficult to repair. It's very difficult to repair, and it will require long time to repair the wind turbine. So several months, in fact, it may require years to repair a wind farmer. That is why the many, especially European nations, are trying their best so that it cannot make any damage by lightning. Okay, because exposure is very high. And another problem is you mentioned already that some wrong information is exist in the market. So actually, some research have been done on the wind speed. I am discussing about wind, not so much about solar, because all of you know about that issue. So some people say Bangladesh is not so suitable for wind power plant because of variation of wind speed and also natural disaster. But many countries, they have Japan as an example, they have natural disaster much more than us. There are so many, maybe every month there is some cycle, some storm. As compared to Bangladesh, they are suffering much more. But I have visited many wind farms in Japan. So if they can overcome, it's also possible for Bangladesh. And we must have to move from the small size wind power project, because the government have taken some initiative like Moheshkhali, Kutubdia, Coxbazar, Shirazganj, and some other places, but they are very small size wind turbines. So as the amount of power we get from this type of power plant is not so high. So we have to move from small size to medium size wind turbine in order to make this technology visible and remarkable for the power system of Bangladesh. Thank you very much. I think you got your answer.
Any question? If no more question, I would like to thank Mr. MD Raju Ahmed, and I also inform you the brief biography of MD Raju Ahmed. MD Raju Ahmed, Life Fellow of IAB, was born in Bangladesh in October 1980 and received BSc Engineering from Chittagong University of Engineering Technology, Chuet, MSc from Bangladesh University of Engineering Technology, Buet, Bangladesh in 2003 and 2006 respectively in Electrical and Electronics Engineering. He received Doctor of Engineering degree from the University of Tokyo, Japan in 2013. He joined Dhaka University of Engineering Technology, Duet, Gazipur at 2004 and has been a professor since 2015. Dr. Ahmed is a member of IEEE. I would like to thanks again Professor Dr. MD Raju Ahmed. Thanks.